Okay, guys, so I'm going to go over, this is 1.1. Okay, and this is example 2. And I just want to talk about the form, first order differential equation. I just want ordinary differential equation. I just want to go over the form where you could see that if you try to get just dy dx equals, right, or when they talk about first order, you're going to have a function of x, let's say a of x, and let's just put a 1, right, just to be different, dy dx. So that's your first derivative going with this is just a coefficient function. Think of it that way. I can't spell. Okay, coefficient function. Okay, meaning that it's going to go with the first derivative because this is the first derivative, even though you don't see that little 1 there. All right, and then plus another function a sub 0 because it's not a derivative of x of our original function equals some function of x. Okay, the only thing these things are, right, are functions of x. Now I know you don't see one here, but a function of x can be 1. You could have a of x equal to 1. That's still a function of x. And then it's equal to another function of x. And that is in the form that you see there, right? Which is this form here. This is ordinary differential equation. So this is a first order because it's the first derivative, okay? Here you can see similarly, right? If we can rearrange some stuff to check to see if it is in that order. So, say you divide, I see what they did here. They multiplied everything by dx, okay, and so they multiply everything by dx. So let's go here, right? So this gives us 6xy dy, right, plus x squared plus y squared dx, all right, and that's equal to 0. Oh, and that's what they have right down here, okay, of that equation. All right, a couple other things I just wanted to put in notation. This n is just talking about like the nth derivative. If it was a 2, it's the second derivative. If it's a 3, it's the third derivative. It's a 4, fourth derivative, and so on. Okay, same idea up here. This is just saying it's a function of x comma y comma first derivative, second derivative, third derivative, fourth derivative, or all the way up to some nth derivative. It could be 2, it could be 1, it could be 100. All right, usually you're not going to see 100, but you could have all those types of derivatives there, or orders to the differential. Like really, if the derivative is the fifth derivative, it's the fifth order, right? If you know that and you have it in this form, and say you solve for that highest derivative that you see, here you're just going to have a function of x and all the other derivatives below it. So if it was fifth, you'll have x, you'll have the function itself, first, second, third, and fourth derivative if it goes to 5. That's what that represents. All right, the last thing I want to go over . Okay. Right, is just talking notation again. All right, this just represents a function of x in front of a derivative, okay? Function of x in front of a derivative. Now, they're saying here is the nth derivative. This is the nth minus 1 derivative. So an example can be, right, let's say I have a function of x. So x squared, right, let's say d squared y over dx squared, right? So the second derivative plus, right? So if it's the second derivative is your largest, the next one down is the first derivative, another function of x, dy dx, right? First derivative. And then again, it ends, right, with a function of x itself times the original function. So let's make this minus 5x with y, right, the original function, and then minus another function of x. Okay, so maybe it's, I mean, it doesn't have to be minus, but it could be plus, say, e to the x, right, equal to 0. Or if we just rearrange it, you'll get that other notation where it's equal to a function of x, right? And here again. So all this represents is just a function of x times a derivative. Okay, function of x times like the derivative below that first largest derivative that you see. Okay, you could see the example here, right, for a second order, and see the example here for a first order. These are just functions of x. So it could be x constant, it could be a 2, it could be x squared, it could be sine x, it could be anything like that. I hope that helps you guys with these examples.